This is geometry, unit 4. We're going to prove triangles congruent using SAS, side, angle, side. The A has to be the included angle. So, for example, here what we're going to be given is two sides we're given two sides that match two sides. Now, if I do it like this, two sides and two sides, this third side is clearly different. So just because you have two sides of one triangle that match two sides of another triangle, it isn't a way to prove triangles congruent. These would not make congruent triangles. But if we come in here and get fancy, we come in here and make this angle, that would be just about like that. And if we would come in here and make this angle the same size as that one, see what we did there? Now I have two sides the same. The angle in between them is the same. And then, of course, my third darker side is the same. What that is going to guarantee us now is that our third side of our triangle has to be exactly the same. Just by having side, angle, side, the A has to be in between the two S's, the two sides. That's going to make our two triangles congruent. So if you make a triangle with a length of, we'll pretend 3, and you make a side with 5 perhaps, then we're guaranteed if this angle in here matches, those have to match, then our third sides are going to exactly match also. Our missing angles are going to exactly match also. The triangles will be congruent if we have two triangles with the side, angle, side pattern. So that is what our lesson is about today, side, angle, side. So what we're going to compare here is RS, that's the 2 ticker side, that's going to match the 2 ticker side, which is UV. Angle R is going to match angle U. Now it's okay to use one letter because we don't have adjacent angles at that location. There's only one angle at R, so it's okay to call it R. So angle U. And then, of course, the last set that they're showing are the same with the 1 tick mark and the 1 tick mark. RT, that's RT, is UW. UW. RT is congruent to UW. If we have that, if we have an S, an A, and an S, it has to be in that exact order. The A has to be in between the two S's. Then we have enough information to prove the triangle is congruent. So RS went down the 2 ticker, went down the blue side, then down to T. RST has to be congruent, the blue and the gray side. So triangle UVW. Notice that the order that you put the second triangle is very important. It has to match the same corresponding order you used in the first triangle. There are 6 correct ways that you could have named that congruent statement. All right. We're going to come on down and we're going to discuss a vocab word called included angle. If you look at the terminology we used up here, if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. So it's that word included, the included angle. So let's look at these 2 sides. Side GH. That is going to be this blue side. We can pretend it has 1 tick mark on it. That is supposed to work with HI. That's going to work with HI. We're not saying that they're the same length. We're just saying that they are 2 segments. What would the included angle between those 2 sides be? What was the angle that's made? We could call that, and here's a little hint. Notice the H's are the same. There's your hint. But angle H, because that's the angle that is formed right here. That's the angle that's formed, is that H angle. So we can call it angle H, or we could use 3 letters. Angle GHI, GHI, or even IHG. So those are the included angle. They're all the same angle, just different ways of naming it. Let's try it now with these 2. If you look over here, you have HI and you have IG. HI and IG. What angle is formed by those 2 segments? The angle that's in between those 2 segments would be right here. Now notice the concern about calling that angle I. We cannot use 1 letter to name this angle, because there are multiple angles at this point. There's multiple angles at point I. There's the angle we're talking about. There's the angle below it down here that is also considered part of I. And then there's the double angles put together. So if you say angle I don't know which one you're talking about. So we need to use, the included angle is angle HIG. Or you could say angle GIH. You cannot use 1 letter. We're going to look down here, decide whether enough information is given to prove the triangle is congruent using side angle side congruence. All right, side angle side. Well, I look here and I see that they have given us one tick mark apiece. So they've given us like a blue side. They've told us that TQ is congruent to SQ. They've told us that. They've also told us that the angle in between those segments, these two angles here, angle TQP, is congruent to angle SQR. They've told us those two angles are congruent. They've also labeled the picture and told us that these two sides are congruent. They've told us that QP is congruent to QR. So if you notice, they have shown us a pair of sides that match, a pair of angles that match, and they've also showed us another pair of sides that match. So I know that triangle TQP is congruent to triangle. I went down the blue side, then I went up the red side. So that would be SQR. S to Q was down the blue side, and up to R is up the red side. SQR. So I know that by side angle side congruence. Kind of helps us think about writing a proof when we write it in this order. When we start to look at the next example, I see that we know that segment NK has one tick mark on it. So does LK. It has one tick mark on it. So I have NK congruent to LK. I know that for sure because the picture's labeled like that. I also have another pair of sides with two tick marks on it. This one right there, and it's congruent to apparently the two tick mark right there. Now I'm going to purposely give myself some room. Okay, we'll call this MK is congruent to JK. It's okay to write them in the opposite order like we did. All right, I should have even left more room. But that's only two S's. That's only an S and an S. I need another bit of information. There's no reason why the third sides are congruent. They're not reflexive. They're not the same exact segment. They're not the midpoint of anything. But if I look closely, I could talk about this angle being congruent to this angle. Kind of that bow tie type of angles. They're formed by a big X. We call those vertical angles. So we could say angle JKN is congruent to angle, I went down the red then the blue, so I'm going to go down the red then the blue, MKL. That is the angle that is in between those two sides. So triangle NKJ is congruent. N to K with the blue side, then the red side. So I need to go the blue side, then the red side. Triangle LKM by SAS Congruence. On our flip side, what we're looking at. We are looking at two triangles that are supposed to be congruent. Now read these directions carefully. State the third congruence that must be given to prove the triangle's congruent by using the given theorem or postulate. So what we're going to do is show two different triangles. One triangle is called ABC. The other triangle is called FED. I'm supposed to know that BC and ED, they are congruent to each other. So they're going to get a tick mark. So they could be considered our blue sides. Then I also am supposed to know that AC is congruent to FD. They both get 2 tick marks. Or we can consider them the red sides. I'm supposed to prove these triangles congruent by SAS. Now, there might not be a reason why the third congruence is true, but what do we wish was true? What would need to be true? I would need an angle the same. So angle C would need to be congruent to angle D. That would be the third congruence that is needed. In my second example over here, I have ABC congruent to FED. And the sides that they give us is that AB is matching FE, and that AC is matching FD. So my third bit of congruence by side, side, side would be BC would have to be congruent to ED. All right, for our proof down here, we have B is the midpoint of AE. That is part of our given information. So if B is the midpoint of AE, we have 2 segments that are congruent. AB is congruent to EB. If midpoint, then 2 congruent segments. I also know that B is midpoint of CD. That is part of the given. When you know you have a midpoint, then you also know you have 2 congruent segments. And the reason those segments are congruent is that if I have a midpoint, then 2 congruent segments are formed. We also know that ABD is going to be congruent to EBC if vertical angles, then congruent angles. The if comes earlier. In this case, the if comes from the picture. So the way we prove these triangles congruent is by a side, and the angle that would be in between. So side, angle, side. We just proved it in a different order, but it's still the 2 sides and the angle in between. Side, angle, side, congruence. For our last example, we have 2 parallel sides. And remember what we're supposed to think about when we see parallel sides. We're supposed to be looking for either corresponding or alternate interior. And in this case, we're going to have the zigzag shape that have alternate interior angles. So we have our given information that the segments are congruent, and we have the parallel sides, which is your arrows, that are going to create our alternate interior angles. So if AB is parallel to CD, then we have our given. If parallel lines, then alternate interior angles congruent. We know these angles are going to be congruent because we have parallel lines. The other part of given information we haven't talked about yet, some people like to make those all up in the same line, or you can separate them. We have our reflexive property of congruence. That's the one that's being shared between the two. So notice that both triangles have a 1 ticker for a side. Both triangles have an angle that's the same, and both triangles share a second side. So it's 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle. So what we're trying to prove always comes down here to last statement. And we did this in the order of a side, angle, side. A side, angle, and a side.